Lesson 8.5, scaled figures, perimeter, and area. The right triangle below is dilated by a scale factor of 2. So you can see the smaller triangle is getting enlarged by 2. Find the perimeter and area of the right triangle below and of the dilated right triangle. So we've got to take all of these sides times 2. So 14 times 2 would make this 28. 48 times 2 would be 96. And 50 times 2 would be 100. And so perimeter of this right triangle, perimeter is just adding up all the sides. So it's 14 plus 48 plus 50, which is 112. Okay, let's go ahead and do perimeter of this one. So it's 96 plus 28 is 124 plus 100 is 224. So I want you to look at that relationship. Can't we say that 112 doubled would be 224? Yes. So perimeter is simple to find. It's just that scale factor applies. Area, though, we've talked about how it's not, and I'll show you why. But first we need to remember, how do you find area of a triangle? And a triangle is really half of a rectangle, just so you know. So if I were to extend this down here, I need to know that it's like a length times a width, but it's half of that, right? If your mom's ever cut your sandwiches in half, so a square or rectangle becomes 2 triangles, it's half, and we call them, instead of length and width, base times height. So it's something that makes a 90 from these two. So in this image, my base to me would be the 48, and I would call my height the 14. You're not using the hypotenuse, the 50, for area. And so it'd be half of 14 times 48. And you can multiply in any order you want. You can take 14 times 48 first, and then take half of that, which is the same thing as dividing by 2. You could do half of 14, which is 7, times the other number, 48. That would also get 336. The order does not matter. But I can't simply say I'm going to double this and get this area. Let's try it and see what the pattern is. So it's 1/2. The base in this picture, I would say, is the 96. And then the height, again, is the 28. And so I'm going to take 96 divided by 2, that times 28. Okay, you can definitely tell that's not doubled. I want to see what the ratio is. So if I took that new area divided by the original area, I get 4. We kind of talked about this, how when you have an area, you're not only changing one dimension, you're now changing 2 dimensions. You're making them twice as big. So if this is times 2, and this is going to be times 2, 2 times 2 now makes 4 times bigger of an area. So that is something to keep in mind to find the area, and we'll try to do that on some of them so it takes us less time. Number 2 is a rectangle. It's a scale factor of 1/2, so it's getting smaller. Find perimeter and area of both rectangles. So half of 46 would be 23. Half of 37, half of 36 is 18, so 18.5. Okay, perimeter of a rectangle is really supposed to be 2 times your width, or 2 times one dimension, plus 2 times another dimension. But again, it doesn't matter how you get there. You can add up 37 plus 37 plus 46 plus 46. I just like thinking, okay. Or you could even take 37 plus 46, these two, and then double that to get these two added with it, so 166. So the beautiful thing about this is the perimeter of this other rectangle will just be half of that. Half of 16 would be 8. Half of 6 is 3, so 83. That one's easy. Okay, area of this rectangle is just going to be length times width of 46 times 37 is 1702. How I could get the area of this one is take our scale factor of 1/2 and think, okay, this is decreasing by 1/2 and this. So I'm having 1/2 times 1/2 for 1/2 squared. 1 times 1 is 1. 2 times 2 or 2 squared is 4. So it's really going to change by a scale factor of a fourth. So you take 1702 times a fourth, which is the same as a quarter, or 0.25. And so I get 425.5. And again, if you wanted to figure out this area, all you'd have to do is take 23 times 18.5, and you would get the same thing. So it's just whatever you like the most. Let's do one more of them. It is different. The rectangle below is the image of a rectangle that was dilated by a scale factor of 5/4. Find the area of the pre-image, the original, before its dilation. So that's important. Our scale factor is important. So our original what do I say? Rectangle, was smaller to begin with, and so it got increased by a scale factor of 5/4, which is bigger than 1. First thing I would do is find the area of this rectangle. The after image is 1575. I don't even have to find these dimensions. You can if you want, but what I'm going to do is take the reciprocal of the scale factor, which is 4/5, and I'm going to square it. Okay, so you're squaring 4 and 5, which would be 16/25. If I take this after image times this new scale factor, that'll give me the area of the pre-image. 1575 times 16/25. Make sure you put parentheses around your fractions if you have a calculator like mine. It would have been 1008 square units. So again, you wouldn't have to do that. What you could do is say, okay, still I need the reciprocal of 5/4, so I could take 45 times 4/5. That's 36. Take 35 times 4/5. That's 28. See how they're smaller and it made them bigger? So 28 times 36 gets me that 1008 as well.